Welcome to the session 2 for the unit 1 of digital signal processing. Let us discuss now basic elements of digital signal processing and its requirements. Before going towards digital signal processing, let us first elaborate, let us first understand analog signal processing. In the analog signal processing, we will have analog input signal, then we will have analog signal processor, and at the output of analog signal processor, we will have analog output signal. Here, both the input and output signals are in analog form. This is because most of the signals are analog in nature. Such signals can be processed directly by appropriate analog systems for extracting the desired information. In this case, we can say that the signal has been processed directly in analog form. So here you can see that the input signal is in analog form. It is directly processed by analog signal processor, and the output is again in analog form. Hence, both the input and output signals are in analog form. Now let us try to understand the digital signal processing. Basically, digital signal processing provides an alternative method for processing the analog signal. Here you can see it is the analog input signal. Then we have A to D converter. Then we have digital signal processor. Digital signal processor processes only digital signals. So to perform this digital signal processing, we need an interface between analog signal and digital processor. This interface is called as A to D converter. My input signal is in analog form and digital signal processor works on the digital signal. So I need to convert the input analog signal into the digital one. So for that purpose, I'm using A to D converter as an interface. The digital processor may be a large programmable digital computer, or it may be a small microprocessor programmed to perform desired operations on input signal. Okay, so digital signal processor can be a computer or a simple microprocessor or microcontroller programmed for doing a specific task. In applications like speech processing, we require to give out the information in analog form. If I want the output signal to be in analog form, I need to convert that output of digital processor into the analog form. And for this purpose, I have to use another interface referred to as digital to analog converter, that is DAC. So digital signal processor, its output is given to D to a converter, and whatever the output I am getting is in analog form now. However, in some digital signal processing systems, we do not require this D to a converter. For example, receiving a data from a radar system. Next, we'll go for the advantages of digital or analog signal processing. In digital signal processing, we can reconfigure the system by simply changing the program. If I want to reconfigure my digital signal processing, I will just change the program and I can reconfigure my system. Well, in analog signal processing, I need to redesign my hardware, I need to retest my hardware, and then I have to verify my hardware. In analog signal processing, tolerances in analog components makes it really difficult to control the accuracy. Accuracy in analog system depends on the tolerances of analog components. Digital signals are easily stored on magnetic media without deterioration in the signal. Digital signal processing allows the implementation of more sophisticated signal processing algorithms, while it is usually more difficult to perform mathematical operations on analog signals. If I want to uh, do the processing for complex programming or sophisticated processing algorithms, I can do it with the help of digital signal processing. But if I want to do the mathematical operations in analog system, it is very difficult to perform those mathematical operations precisely. In some cases, implementation of digital signal processing is cheaper than its analog counterpart, and that is because of the cheaper digital hardware. In spite of all these advantages, DSP has its own limitation of speed of A to D converter and digital signal processing. The signals which have extremely wide bandwidth requires the faster sampling rate ADC and fast digital signal processors.